going to try to figure out how to factor this. And whenever you're factoring, we always want to think, well, especially if A is big or the whatever. So let's think, is there a greatest common factor? So this is where you always want to first start. And when you think about greatest common factor, we're thinking about what can they all be divided by, right? What is the biggest thing they all can be divided by? So as far as the numbers, I got an 18, a 36, a 27. Well, we see all of those can be divided by 9. So I know I can divide all of those by 9. And so I know I got a 9 out front. And let's see, as far as the letters, let's see, so letters, x squared, so I have an x squared, an x cubed, and an x cubed. So they all have at least x squared in them, so I can take out an x squared. So we're dividing them all by x squared as well. And let's see what is else. So I got a y here, so I have a y squared, a y cubed, and a y. So they all have at least one y, so I can divide them all by the one y. And so if I do that, then what is left? All right. Well, I know 18 divided by 9 is 2. I know that x squared divided by x squared is nothing. I know that y squared divided by y is a y. And then that's the first term. And then 36 divided by 9 is 4. X cubed divided by x squared is x. And y cubed divided by y is y squared. And then x cubed divided by x. So then I got a minus. 27 divided by 9 is 3. X cubed divided by x squared is x. And y divided by y is nothing. And there is our answer. And so our choice is answer choice C there. So normally we would also think, is there any way to factor this any further? In this case, there is no way to factor this any further. There's nothing common. There's no squared terms on both. So we can't go any further. So that's as far as we go on that one. All right, number 2, we know I'm just trying to factor this out. So x squared and x would give me x and x. And then factors of 120 that make a 2. So I want things that maybe are close to factors of 120. We know 1 and 120. I'm not going to go through all of these, but let's see, we know 10 and 12. Well, 10 and 12 would make a 2, right? So I know 10 and 12. And so in order to make the negative 2, this would have to be negative and this would have to be positive. And so I got x plus 10 and x minus 12, x plus 10, x minus 12, and there's our choice A. All right, for 3, we know we're also breaking these apart. So let's see, I got 2x and x, and then factors of 28. So let's see, factors of 28, 1 and 28, 2 and 14, 4 and 7. So let's try 4 and 7 maybe. Let's see, 4, 7. That would, if I cross multiply, that would give me 8. That would give me 7. And yes, that does make a positive 1 because 8 minus 7. 8 minus 7 equals 1. So that means this has to be minus, this has to be plus. So I'm looking for 2x minus 7 and x plus 4. 2x minus 7 and x plus 4. There is our answer. All right, so longer word problems that look like this. Well, the first thing I always do is scan and find an equation. So we're going to look, here's my equation, and I notice these are all equations, and it says which one is equivalent to this above. Well, let's see, what is equivalent to that above? Well, I'm going to get rid of these parentheses because they really don't mean anything. So I got NP plus NG plus NC. So what do we always say? Think maybe greatest common factor. Is there something that they can all be divided by? Yeah, they all have at least an n, right? So that means I can pull an n out and make this P plus G plus C times n, because the n is all common. And so I got n, P plus G plus C, and look, there's our answer right there is A. And why is the parentheses don't mean anything here? Because this is just separating. It's just like 2 plus 3, right? The parentheses don't mean anything. They're not saying multiply. There's a plus sign there. Now if that NC was times, then that would be different. So if this plus sign wasn't there, then the parentheses would be needed. Okay, for this one, let's see, I always think greatest common factor first, right? So in this case, 36 and 100, well, maybe they both can be divided by 4. So let's do that. Let's divide them both by 4. Okay, so there's that. So, and they both have an x, so let's take out the x as well. So now I'm going to do 4x on the outside and make that then 9 minus 25y squared. And I'm going to just rewrite that and change the order of that just so it looks a little bit neater. So I'm going to do 4x and make that 25y squared minus 9, just so we see it like we normally see it. Right? What does that mean? Well, this I can factor. I got a square root and a number, right? Here, a is 25, b is 0, and c is negative 9. So I can go ahead and factor that out. Well, that's 5y, and then factors of 9, 3, and 3. And we know we want to make them to 0, so that would give me 15, 15, and then 1 plus 1 minus. So I got the 4x, 5y plus 3, 5y minus 3, 5y plus 3, 5y minus 3. And there we go. Answer choice is B. All right, number 6. Well, this one we have 4 terms, so we can do what we call factor by grouping. So we are going to group them. Remember how we did this? We're going to take the first 2 terms and we're going to see, well, what do they have in common? So when you factor by grouping, you group them and then you do your GCF. And so this would be a 4. They both have at least a 4 in them. They both have at least one A. And they both have a B. So I'm going to divide it out by 4AB, and that's going to leave me just with the A in that first term, and then minus 3. In the same way here, we're going to divide them out both by 5, so group those together. They both have at least a 5, so I'm going to divide them out by 5, and that's going to leave me A minus 3. And then you just put your groups together. We know that's, so this was, so I can put the 2 things that are just, right, on the outside together. So I've got 4AB plus 5. That's one thing. And then the other we put together is just the A minus 3. So I got 4AB plus 5 and A minus 3. 4AB plus 5 and A minus 3. There is my answer choice, D. All right, for number 7, we have one solution is 1/3, so which equal to 0. So let's just go ahead and actually factor this out. So I got 3x and x, factors of 5. Let's see, 5 and 1, right? So that would make 15, and that would make 1. And in order to make a negative 16, they both have to be negative. So both negative. Set them both equal to 0. So I got 3x minus 1 equals 0. And we also have x minus 5 equals 0. And so this would give me the 3x equals 1. And this would give me x equals 5. And this is where we get the x equals 1/3 as one solution. And the other solution is x equals 5. There is our answer there. All right, for 8, it's saying, what is the sum of the solutions to the problem? Well, we know in order for these to equal 0, all we do is take what? We just take each group and say x minus 3 equals 0. And so this just says x equals 3. And we also say x minus 4 equals 0. That's our 0 product rule, right? So x equals 4. And so the solutions, those are our 2 solutions. And it says, what is their sum? Or what is 3 plus 4? And the answer to that is just simply 7. Alright, this, if f of x is equal to 10, okay, so what does that mean? That means I'm putting 10 in place of f of x. So I have this problem, 10 equals x squared plus x minus 20, and we actually want to factor that out. So don't get distracted and keep the 10s over there. A and B is definitely wrong, because what do we know we have to do? We know we have to move the 10 over and set it equal to 0 in order to factor out. Right, so this would be x squared plus x, and then minus 30, and now I know I'm factoring that, x, factors of 30 that equal 1, so factors of 30, 1 and 30, 2 and 15, 3 and 10, 5 and 6, and there we go. We know we can use 5 and 6 to make a 1. Right, it's got to be positive, so this has to be positive, has to be negative. So I got x plus 6, x minus 5, x plus 6, x minus 5 equals 0, and our answer choice is C. Right, D would have to be what? If this was a negative here. So if it was negative x, the answer choice would be D. Okay, for 10, let's go ahead and just factor this guy out. So I got 3x and x. And we want factors of 10, so I know it has to either be 1 and 10 or 2 and 5. Let's try the 2 and 5. Let's try 5 and 2 here. And we need to make a positive 13, right? So that gives me 15, that gives me 2. And in order to make a positive 13, it would be 15 minus 2. And there's minus, that's plus. So 3x minus 2 and x plus 5. 3x minus 2 and x plus 5. There's our answer choice A. Alright, for 11 here it says, which of the following simplified expression represents the area? So we know area equals length times width. So length is x plus 6 and width is 2x minus 3. And we know we have to multiply those. So remember, when we're multiplying, all we're really doing is just distributing. So x times 2x would give me the 2x squared. So now I know C and D are definitely wrong. So x times negative 3 would be negative 3x. And then we're going to also multiply this out. 6 times 2x would be plus 12x. And 6 times negative 3 would be negative 18. And just combine our like terms. So I got 2x squared plus 9x minus 18. 2x squared plus 9x minus 18. There's our answer choice A. Okay, for 13, I know all I'm really looking at, it says, what is the value of the positive x-intercept? Well, we know x-intercepts are the same things as roots, or that's also when we solve it out, when we get x equals, right? So when I get x equals, that's what these things mean. So that means that I'm looking for when is y equal to 0. So we'll just... So once again, looking for when is y equal to 0, because that is the x-intercept. So we're just going to factor this out. X, factors of 3, 3, and 1. Got to make a negative 2, so it has to be negative, it has to be positive. So that means I have x minus 3 equals 0, and x plus 1 equals 0. And so this is x equals 3, and this is x equals negative 1. And it says, what is the positive x-intercept? So this is my positive x-intercept. This is what we're looking for. X equals 3. All right, here I'm looking for what is the difference of the roots. So we know we are subtracting the roots. Okay, so I get one of my roots. So we got to, in order to find the roots, we got to either factor it out, or we could use the quadratic formula, whichever one you want. So quadratic formula, negative b plus or minus square root b squared minus 4ac all over 2a. So we could use that if we wanted to. So I get 3x and x. This gives me then 5 and 1. Well, does that work? Nope, that doesn't work. Got to switch them around. 1 and 5. That would make 15 and make 1. And so that would be then plus. So they both would have to be minus, both have to be minus. Oops, that's supposed to be minus. Okay, and then so I got x equals 1/3 and x equals 5. And you notice this is also the same as the previous problem. We're looking for what is the difference between the roots. So if I took 1/3 minus 5, and I should say absolute value of the difference, right? So it should say absolute value of the difference because we can't have negative. So how do you do 1/3 minus 5 or 5 minus 1/3? Doesn't matter which way you do it because we're looking for the positive value. In order to do that, we have to make common denominators, so make them both into 3's. So I'd have to make them both where the bottom of the denominator is 3. So instead of being a 1, it goes up to 3, so it multiplies by 3. So that'd be 15 minus 1/3, or 14/3. And that would be our answer there. All right, how many times does a graph of this cross the x-axis? We're not looking at all for graphing. We're just looking at what? We're looking for what are my x-intercepts? Are they real? So if your x-intercepts are real, that means they cross the x-axis. If they are not real, or if they are imaginary, and how do we get the imaginary value? Remember, you get square root of -1. So if they are imaginary, then they don't cross the x-axis. So this is one where we really need to look at the quadratic formula. So we are not graphing these, right? Even though it does say graph, we're just looking for, are they real? So if they were real, they would either give us 2, right? We got 2 potential answers, or they could be the exact same answer and we could get 1, or in this case, or they could be imaginary and give us none. 3 is not an option in this case because they can never cross 3 times. There's not 3 answers. It's only squared. So those are the concepts that we need to kind of be familiar with. Is imaginary would give us 0 times, the same root would give us 1 time, or normally it gives us 2 roots, or 2, right? So normally it gives us 2 roots, 2 x-intercepts when we actually solve this out. So let's go ahead and plug this into the quadratic formula and see what we get when we do this. Okay, negative b. So we know a is 2, right? So a is 2. We know b is -3, and I know c is 2. So I get negative b, so I get 3 plus or minus square root of -3 squared minus 4 times a, which is 2, times c, which is 2, and that is all over 2 times 2. So let's see. I'm going to work out what is this inside the square root part. So leaving everything else alone, 3 plus or minus square root. -3 squared is 9, so that gives me 9. -4 times 2 times 2, so that would be -8, and -8 times 2 would be -16, all over 4. Okay, so let's see, what does that give me? Well, that says 3 plus or minus square root. 9 minus 16 is -7, all over 4. Well, okay, so now I have a negative inside of square root. What does that mean? That means that it is going to be imaginary. So if it's imaginary, it cannot cross the x-axis. That means it crosses the x-axis 0 times. Okay, and last one, we're just looking for what are the roots of y, and so we're looking for what are the roots when we're looking for the x-intercepts for when y is equal to 0. So we're just going to factor this out. 2x and x, factors of 48. Okay, so 1 and 48, 2 and 24, 4 and 12. Alright, so I got 3 and 16, 4 and 12, 6 and 8. Alright, let's see. What are my options here? It doesn't look like any of those. Did I do anything possibly wrong? Oh, maybe. Let's go through. Okay, so let's try 6 and 8. You know, let's do 6 here. Let's do 8 there. That gives me 12. That gives me 8. Right? Does that make a 10? Nope, that doesn't make a 10. So let's try a different combination. Let's try 8. Still using the same ones. Let's do 8 here and 6 there. That gives me 16 and 6. Yeah, I can make a 10. So 16 minus 6, there's minus, there's plus. So I get 2x minus 6 equals 0 and x plus 8 equals 0. So this gives me 2x equals 6 or x equals 3. And this gives me x equals negative 8. So I got 3 and negative 8, 3 and negative 8. There we go. All right. This problem you could have also seen if you had paid attention, right? You could have also seen that you could have done GCF first, right? So always think, is there a potential for GCF first? So I could have divided them all by 2. So if you divide them all by 2, that just leaves me x squared plus 5x minus 24. And you could have factored that, and guess what? You get the same answers, x, x, and factors of 24 that make a 5. Right, so it'd be 8 and 3. Right, so that would be plus, that'd be minus, and we should get x equals negative 8 and x equals positive 3. Why do we not do anything with the 2? Because 2 cannot equal 0. So there, you wouldn't do anything with that out there unless it was a variable. Right, so hopefully this helps. Good luck, and you guys will have your test tomorrow for honors and non-honors test on Wednesday, Thursday.